All right, let's take a look at 22, 23, and 24. Finding all the zeros. And in 22, 1 has already been given. So it's giving you a hint right here with that I that at some point you're going to have the square root of a negative number. So that's just kind of a hint in this whole process that at some point you're going to have the square root of a negative number. That's where the I comes from. So for this particular problem, we're going to set it equal to 0, x to the third plus 3x squared plus 4x plus 12. I'm going to do this by using the grouping method. So I'm just going to group these, and we're going to factor something out and see if we can't get the same thing. So out of this, I'm going to factor or pull out an x squared. So when I say factor, you're imagining that you're dividing it out. So it's like we're going like this backwards. You understand that. So it's going to be x squared. And then that's just going to be x and plus 3. There we are. Again, taking a look here. Ask what we can factor out, and it looks like we can take out a 4. Again, we're taking it out like so. And I'm just going to do blue here. So we're taking out a positive 4. And what is left is going to be x plus, oh, looky there, 3. It matches. Wonders. So this is a match. So we're going to have x squared plus 4 and x plus 3, and that is going to be our zeros. So now we simply solve that. So I have x squared plus 4 equals a 0, and x plus 3 equals a 0. And for here, of course, we simply minus 3, and that's an easy one. So one of our zeros is going to be a negative 3. Taking here, we're going to do obviously minus 4. Now you can see where the negative comes from. X squared equals a negative 4. And of course, opposite of squaring is square rooting. But whenever you're doing a square rooting, you have to watch out that there is both a positive and a negative version. Square root of 4 is 2, but we do have the square root of a negative 1 there. So we have positive 2i. We're going to have negative 2y. So for this particular problem, your total number of zeros is positive 2y, negative 2y, and negative 3. Coming here to problem 23. Okay, this takes a little bit of footwork, but if you color code this, so I recommend you get some sort of colors out. The colors I have available is red, green, blue, and yellow. So if you happen to have these colors, they come in real handy. So first off, we're going to start with the basics. And the basics is I can factor something out of all of these. So kind of one of the rules is if you can factor it, you immediately should. And so we're going to take out an X out of everything, obviously. So we have here, let's go ahead and we are pulling out an X. So I'm going to have an X here. And then what's left, of course, is going to be 2x to the fourth minus x squared minus 3. Now, you're used to seeing polynomials. This is how you know when you want to substitute. You're used to seeing polynomials, the standard form, ax squared plus bx, plus or minus c. That's your kind of like your standard form. And you're like, this looks suspiciously like that, except my exponents are too high. So there's a little bit of a trick here. What we're going to do is we're going to take x to the second, and we're going to replace it with a different singular variable just so we can easily manipulate it in a form that is more familiar to us. So and you can take any variable. It really doesn't matter here. So I'm going to replace it with the variable, I don't know, u. Okay. So one step at a time here again. So just keep track of what we're doing. We are going to replace wherever x squared is with the variable of u, singular, and you'll see why that's helpful in just a moment. Okay. So keep that x on the side. We're just going to kind of leave this red x over there, and we're going to take this and rewrite it as 2u to the second. You're like, wait a minute, where did u to the second come from? Well, I'm defining u as x to the second. So if this is already x to the fourth, therefore it's 2u to the second. Why did I do that? Because now, oh, it looks suspiciously similar to that. All right, and that's where we're going with it. We want it to look like something that's a little bit more familiar. And we're going to keep going. Again, I'm going to replace that x squared with u minus 3. Oh, that looks a lot simpler. So we call this Xbox at my school. I don't know what you call it, but the idea is this: u times a times b, which in this case is -6. Excuse me, a times c. And then you put your b term down below, which is -1. So you're asking yourself, what are factors of 6 that add or subtract to -1? And we know those factors, of course, are 2 and 3. And because the 1 is negative, we know our larger number is going to be the negative factor. Now we're going to do this by grouping here. So I'm going to have 2u squared minus 2u, excuse me, plus 2u, that's plus, minus 3u minus 3. All right, so that this portion here is these components right there. Now, I'm going to group it to make it a little bit easier to work with. And I can pull out of this a 2 and a u. So we're going to pull that out. So I have 2u out, and then what's left is u plus 2. So you're kind of thinking ahead here on the right-hand side. I want, I made a mistake right here. This is right here, supposed to be. Oh, that was correct. Excuse me. That is still 3. This is where I made my mistake. This turns to 1. There it is. Got it. This one on the right-hand side, I kind of want this to be u plus 1. That's how we kind of do grouping. So in order to do that, I'm going to take out a -3. So I'm going to divide both by -3 and take it out. And lo and behold, oh, I've got u plus 1 now. Looky there. So we do our final grouping. We have 2u minus 3 times u plus 1. I'm going to bring down this x. Now we're going to take back in our u being replaced by x squared. So we're going to take that x squared and put it back in where it belongs. We just used the substitution method so that it made it a little bit easier to factor that out with doing a fewer gymnastics here. So we're going to have x and then 2x squared minus 3. and then x squared plus 1. There you go. And all of that is equal to zeros. Now we break it down, and our first x is 0. Woohoo, that's it, because just x equals 0. And we have 2x squared minus 3 equals 0. And then we have x squared plus 1 equals 0. Let's focus on this middle term. We are going to add 3. And we get 2x squared equals 3. We're going to divide by 2. And we have x squared equals 3 over 2. The opposite of squaring is square rooting. All right. But wait, there's more, because technically this is root 3 over root 2. And of course, this entire thing's going to be plus or minus, but we'll come back to that. You cannot leave a radical in the denominator there. So we're going to multiply top and bottom by root 2 to clear that radical in the denominator. So x is going to equal plus or minus 3 times 2 is 6. So root 6 over 2. There's those two. Coming back up here, last one. A little bit of a caveat here, minus 1, minus 1. Of course, you have x squared equals negative 1. Oh, golly, back to imaginary numbers, our favorite here, square root, square root. So now we have plus or minus, and of course, the square root of 1 is 1, but you have an imaginary number in there. So we have plus or minus 1i. So your total count of zeros here zoom back out, is, okay, there's 1 0, and then you have plus and minus, which counts as 2, root, a little bit of a lag here, root 6 over 2, and plus and minus 1i, or just I, is sufficient for that. That one is, where were we, 23? 23. All right, coming to 24. Clear all that work. Taking a look here. All right, so when you see a problem like this, you know you're going to be doing a bunch of grouping, and you kind of have to keep this template in mind. We're trying to find something that sniffs of this. Okay, just kind of keep that in mind as you're doing this. So we're going to regroup a few things, and I'm going to regroup the odd exponent with the odd exponent. You'll see why that's helpful in just a moment. So we're going to have here negative x to the third minus 9x. And then I am going to group here the even exponent with the even exponent. And that's going to be plus x to the fourth plus 7x squared, and then minus 18. And there's no harm, no foul here, because everything's plus or minus. We really haven't changed any values. We've just moved stuff around. Okay, so the first thing we're going to do is we're going to factor out what we can by grouping here. So I'm just going to do this one little, that one's easy. We're going to take out a negative x squared, because if you can take out a negative, and you can, you should. So we're going to take out a negative x, excuse me, not x squared, just an x. I'm dividing out a negative x. So I have negative x, and then this becomes x squared plus 9. That's good to go. Okay, remember, here is the trick. You're trying to get something that sniffs of this. All right, the problem is I have x to the fourth and x squared instead of x squared and x. So what I'm going to do is I'm going to redefine x squared as a singular variable so it's easier to work with. And again, I'm going to just substitute u, just come up with the same variable each time. And the reason why I'm doing that, again, you're always trying to make something look like the standard form. So we're going to substitute x squared just with and redefine it as u. So this is going to become plus u squared. I think you can see where I'm going here with this. X squared becomes plus 7u minus 18. Okay. Now we're in business. We have something that actually looks like the standard form. So you multiply a times c, that's negative 18. We're trying to get positive 7, and you're asking yourself factors of 18 that would subtract a 7. And we know that's going to be 2 and 9. Our final component is positive, so that means our larger stays positive, and that becomes the negative, and that's where the negative 18 comes from. All right, for now, I'm just going to work on this side. So we are going to have u squared, all right, and minus 2u plus 9u minus 18. That's a good grouping because you can see what you can take out there. We're going to group here and group here. I can take out a u. So I'm going to divide out a u for both. Come out. So I'm going to have u parentheses, and that's going to be u minus 2. Working. It's working. And here I'm going to take out a 9. And I can do a positive 9 plus 9. And that's, oh, looky there, u minus 2. Woohoo! We got the same thing. So exciting. And so we have, let me get my color straight here. We're going to have u plus 9 and then u minus 2. All right, that's where we're at. And then we're going to bring down what we originally had with our x's, which is up here, and resubstitute. So I have negative x, parentheses, x squared plus 9. All right, now that we have that factored with the u, we keep in mind our definition of u is x squared equals u. So I'm going to bring back that definition of x squared. So I have negative x, and I have x squared plus 9, and x squared plus 9, and x squared minus 2. Dropped a plus sign, I think, here. Yes, there's a plus sign. There's a plus sign right there, plus sign right there. Okay, so out of all these terms, I'm going to pull out that common term. So I have negative x squared plus 9 now times x squared minus 2. Okay, so keep in mind you're trying to do stuff with this x squared plus bx plus c. And you can see here that this negative x is kind of floating off in space. So we're going to bring it over here closer to this component, x squared plus 9. And I'm going to do this x squared minus x minus 2. Why did I do that? Oh, because once again, it looks like the standard form. Then we factor this x squared plus 9 And we have A times C, -2. We have our B right there, which is -1. We know we have a 2 and a 1. Our larger needs to be there, so it's going to be x minus 2 and x plus 1. There is the complete rendition factoring right here with these two. And all of that, keep in mind, is equal to 0. So when we break it down, x squared plus 9 equals 0. X minus 2 equals 0. X plus 1 equals 0. And we take it from there. Minus 9 minus 9. X squared equals -9. Square root. Automatically, I know I have an I, and it's 3. And then plus or minus. So there's two versions there, technically. So x equals plus or minus -3i. Plus 2, that's an easy one. So x equals 2. So far we have 3 zeros. And here, of course, -1, x equals -1. So we have a total of 1, 2, 3, 4 zeros for this particular problem.